Okay, so you're given a picture with this one, but we could quickly reproduce it or draw it ourselves. That's constant at 25. This is the ladder, and it's sliding down the wall this way. We're also given some more information. Let's see. Ladder 25 feet long against the wall of the house. The base of the ladder is pulled away at 2 feet per second. Okay, so we might need that. So let's see. If I call this X and I call this Y, then this is moving at 2 feet per second. Okay, so that would be dx dt is positive 2 since it's increasing. Okay, so I'll just write that down. Here's my normal process. I would first create an equation that relates the variables that I'm interested in, or particularly this variable, which is theta, which is the angle that they're asking about. Find the rate at which the angle between the ladder and the wall is changing. The base of the ladder is 20 feet from the wall. Okay, so I know 25, and I know dx dt, so my intuition says go with the sine of theta, because that's going to be equal to opposite over hypotenuse. Okay, and my step 2 will always be to state what's given, right? So the given rate is dx dt. I already wrote that down. And my step 3 will be to find what we want to find, and that's d theta dt when base ladder is 20 feet from, when x is 20. Okay, so let's see if that's enough information after we do the calculus. So now we're going to take the derivative with respect to time, right, both sides. And the derivative of the sine function is the cosine function. So cosine theta, don't forget your chain rule, d theta dt. And then this is just 1/25th times the variable x. So we could say 1/25th dx dt. Okay, and now we have, we know that that's 2. So I can fill that in, 1/25th of 5 times 2. And then the sine is cosine theta, right? Cosine theta is y over 25. So I bring in y kind of out of nowhere, and then d theta dt is what we're trying to find. All right, so works like the rest of them. We set up our variables, we state what's given, we figure out what we want to find, then we do the calculus with respect to time using the chain rule, and then we're just trying to fill in what we can. The interesting part about this one is we don't have x. Well, yeah, we don't have x because we just have dx dt, and we don't have theta by itself. We have the cosine of theta, which when I figure out what the cosine of theta is, it's y over 25. The question is, what's y? All I need to do is find out what y is, and then I can answer d theta dt. So y would be at the snapshot in time. Notice I didn't put 20 here to start with because x is changing. It's a variable. Y is changing. So the moment in time we're interested in, freeze frame right here, is what rate is theta changing at this moment in time when x is 20 and the hypotenuse is 25. So if you do your Pythagorean theorem, that's really a 3, 4, 5 triangle, I think, right? Or you can do Pythagorean theorem, 25 squared equals 20 squared plus y squared, and figure out what y is. Either way, it should give you 9. Oh, that doesn't sound right. If you divide that by 5, divide that by 5 times 5, 15. So what I did there was I took a shortcut, right? There's a Pythagorean theorem, 3 squared plus 4 squared equals 5 squared, right? So this is just a similar triangle. When I multiply everything by 5, I just stretch out my 3, 4, 5 Pythagorean triple by a factor of 5, and I get 15, 20, 25. Okay, or just do the Pythagorean theorem, and you'll get 15 there. Okay, so that means y is 15, and from there you should be good to go, right? Our goal is to get everything but the rate they're interested in, which is d theta dt. And then if I divide both sides by 15 over 25, which is the same as multiplying both sides by 25 over 15. And I get 2/15, and that should be radians per second. Sorry, radians per second.